Some more types of questions that we can get in relation to rationalizing the denominator is if we get a fraction which looks like this. Now, when we get something that looks like this, we can't just simply multiply by the surd, because if we did that, we would get 2 root 3 over root 3 plus 3. So we've got rid of this surd here, but now we've created another one. So the way we would answer this is we would need to multiply by this denominator again, but we will need to change this sign. So we're going to multiply by 1 minus root 3 over 1 minus root 3. So before, where we would just multiply by the surd itself, whenever there is a sign in the denominator, add or minus, we just multiply by the whole denominator and we flip the sign. So this will give us 2 minus 2 root 3 over 1 minus root 3 plus root 3 minus 3. And the reason why this works is because once we flip the sign, we now get a minus surd and a plus surd, which cancel each other out. So we're left with an integer at the bottom. 1 minus 3 is minus 2. This can be simplified further. So it'll be minus 2 over 2, minus and a minus is a plus. 3 equals minus 1 plus root 3 as our final answer. So the rule we need to follow when it comes to this is if we have 1 over root O, we multiply by the denominator and we flip the sign. I've got a question here. Show that 5 plus 2 root 3 over 2 plus root 3 can be written as 4 minus root 3. Now, it's a fraction that has a surd at the denominator, but there is a plus sign as well. So we know that if we want to rationalize this, we're going to have to multiply by the denominator, but we're going to change this sign. So that will give us 2 minus root 3 over 2 minus root 3. Now multiplying across, we get 10 minus 5 root 3 plus 4 root 3. Plus and a minus is a minus, 3 times 3. So 2 times 3 is 6. Over 4 minus 2 root 3 plus 2 root 3 minus 3. So now we need to collect the like terms. 10 minus 6 is 4. Minus 5 root 3 plus 4 root 3 is minus 1 root 3. For the denominator, minus 2 root 3 plus 2 root 3 cancel out, so we're left with 4 minus 3, which is 1. So our final answer is 4 minus root 3, which matches the answer given in the question. We've got another question here. Show that 3 root 3 plus 3 over 3 plus root 3 can be written as just root 3. So again, there is a surd on the denominator, so we know we need to rationalize it, but there is also a plus sign, so we know to rationalize this fraction as a whole, we need to multiply by the whole denominator and flip this sign. That will give us 3 root 3 plus 3 over 3 plus root 3 multiplied by 3 minus root 3 over 3 minus root 3, and again multiply across 9 root 3 minus 9 plus 9, positive and negative is a negative, 3 root 3, the denominator 9 minus 3 root 3 plus 3 root 3 minus 3. Now collecting the like terms, 9 root 3 minus 3 root 3 is 6 root 3, minus 9 plus 9 cancel out. For the denominator, minus 3 root 3 plus 3 root 3 also cancel out, so we're left with just 9 minus 3, which is 6, and 6 over 6 can cancel out 2, so we're left with just root 3, which is our final answer. So we've got two fractions here which need to be simplified. Please pause the video here and attempt them. Show all of your working out, and we will mark these together once you're done. Now, as we can see here, both of these fractions have surds in the denominators, so they need to be rationalized, and they also have signs, so we know how we're going to work this out. Starting off with the first one, we're going to multiply by the denominator while flipping the side. Now if we multiply across, that will give us 48 plus 6 root 2 plus 8 root 2 plus 2. The denominator, 64. Now collecting the like terms, 48 plus 2 gives us 50. 6 root 2 plus 8 root 2 gives us 14 root 2. The denominator, plus 8 root 2 minus 8 root 2 cancel out. So we're left with 64 minus 2, which is 62. Now looking at this fraction here, these three integers are all even numbers, and it looks like we can simplify this further. So we can divide by 2 to start off with. So if we divide all of these numbers by 2, that'll give us 25 plus 7 root 2 over 31. And now looking at these numbers, there is not anything else that goes into them. 7 and 31 are prime numbers. It can't be simplified further. So this is our final answer. Looking at the second question, again, same process. We're going to multiply by the denominator, but flip the sign. plus root 5 plus 5 over 1 plus 5. Again, let's collect the like terms. Plus root 5 minus root 5 cancel out, so we're left with 1 minus 5, which is minus 4. These integers can't be cancelled out any further, so this is our final answer. Now if you got all of those questions correct, well done. The last video in this series for Surds will be looking at Surds questions from previous past papers and working through them.